NFPA 70, the National Electrical Code, Article 300.3 covers general requirements for wiring methods. Section B addresses metal raceways, stating that metallic raceways, boxes, cabinets, fittings, and other metal non-current carrying equipment must be electrically continuous throughout their length. Specifically, Item 1 says where a rigid metal conduit is used as a grounding path, all lock nuts and couplings shall be made uptight and shall be of the type designed for use on rigid metal conduit. Article 348 pertains to rigid metal conduits. Section A discusses use of line rigid metal conduit under the following conditions. 1. In wet or damp locations where steel raceways are not subject to severe corrosive influences, and 2. Where protection from physical damage is required. Article 362 addresses galvanized rigid metal conduits. Section A covers uses permitted, saying that galvanized rigid metal conduits are permitted in conformity with applicable provisions of Article 348 and are also permitted in the following situations. 1. Where subject to severe corrosive influences, and 2. For exposed runs in corrosive atmospheres indoors or outdoors. Based on these NEC articles, the code does not specifically prohibit the use of galvanized rigid metal conduits inside a sealed metal structure that has been pressure tested. The key is ensuring the conduits meet the requirements outlined in Article 348, particularly regarding their suitability for the environment and protection from physical damage. If these conditions are met, using galvanized rigid metal conduits in such an environment is permissible according to the NEC. There are also some additional considerations. The request for stainless steel conduits might stem from concerns about potential corrosion. Explain that galvanized rigid metal conduits are designed for corrosive environments and comply with NEC standards. Consider the cost difference to meet the budget if needed. If concerns persist, explore alternative solutions such as applying a corrosion-resistant coating to the galvanized conduits or using non-metallic conduits in areas with high corrosion risk. Understanding the specific environmental conditions within the sealed structure is crucial. Factors like humidity, temperature, and the presence of any corrosive agent should be evaluated. If the environment is indeed highly corrosive, even galvanized conduits might require additional protection or a different material altogether. Verify that all connections and fittings used with the galvanized rigid metal conduits are also suitable for corrosive environments. Using incompatible materials can compromise the integrity of the system and lead to premature failure. The NEC emphasizes the importance of proper grounding for metal raceways. Ensure that the galvanized rigid metal conduits are properly grounded to provide a safe path for fault currents. This typically involves using grounding bushings and bonding jumpers to connect the conduits to the grounding system. Conduct a thorough inspection of the installed conduits to identify any potential points of weakness or corrosion. Pay close attention to areas where the conduits are joined together or where they pass through walls or floors. Document all aspects of the installation, including the type of conduits used, the grounding methods employed, and any special considerations taken to address corrosion concerns. This documentation can be helpful for future maintenance and inspections. Continuously monitor the condition of the conduits over time to detect any signs of corrosion or deterioration. Implement a regular maintenance program to clean and inspect the conduits and to address any issues promptly. Consider the specific requirements of the pressure test conducted on the sealed metal structure. Ensure that the installation of the conduits does not compromise the integrity of the structure or its ability to withstand pressure. Adherence to industry best practices is vital for electrical installations in potentially corrosive environments. This includes using appropriate installation techniques, selecting compatible materials, and implementing effective corrosion control measures. Consider consulting with a qualified electrical engineer or corrosion specialist to obtain expert advice on the selection and installation of conduits in the specific environment. The NEC is a comprehensive document, so familiarize yourself with all relevant sections to ensure full compliance. Understanding the intent and application of the code is essential for safe and reliable electrical installations. Always prioritize safety when working with electrical systems. Follow all applicable safety procedures and use appropriate personal protective equipment. If there is uncertainty regarding the suitability of galvanized rigid metal conduits for the specific application, it's always best to err on the side of caution and explore alternative solutions. This might involve using stainless steel conduits, non-metallic conduits, or a combination of different materials. Effective communication with the client is paramount. Explain the rationale behind the decision to use galvanized rigid metal conduits and address any concerns they may have. Document all communications and decisions made regarding the installation of the conduits. This can help to avoid misunderstandings and ensure that all parties are in agreement. Consider conducting a risk assessment to identify potential hazards associated with the use of galvanized rigid metal conduits in the sealed metal structure. This assessment can help to determine the appropriate level of protection required and to identify any necessary mitigation measures. In some cases, it may be necessary to obtain approval from the local electrical inspector before proceeding with the installation. The inspector can provide guidance on code compliance and ensure that the installation meets all applicable requirements. The NEC is not a substitute for sound engineering judgment. Always exercise caution and consider all relevant factors when making decisions about electrical installations. There are several types of corrosion, and different metals react differently to specific corrosive agents. The type of corrosion that is most likely to occur in the sealed metal structure will depend on the specific environmental conditions present. The rate of corrosion is influenced by factors such as temperature, humidity, and the concentration of corrosive agent. Understanding these factors is crucial for predicting the lifespan of the conduits and for implementing appropriate corrosion control measures. Galvanized rigid metal conduits are typically coated with a layer of zinc to provide corrosion protection. The zinc coating acts as a sacrificial anode, meaning that it corrodes preferentially to the steel base metal. This helps to protect the steel from corrosion, even if the zinc coating is scratched or damaged. The thickness of the zinc coating is an important factor in determining the level of corrosion protection provided. Thicker coatings generally provide better protection. There are different types of galvanizing processes, each of which produces a different type of zinc coating. Hot dip galvanizing is a common process that produces a thick, durable coating. Electrogalvanizing is another process that produces a thinner, more uniform coating. The choice of galvanizing process will depend on the specific application and the level of corrosion protection required. In addition to the zinc coating, galvanized rigid metal conduits can also be treated with other coatings to further enhance their corrosion resistance. These coatings may include paints, powders, or other types of protective films. The selection of an appropriate coating will depend on the specific environmental conditions present and the desired level of protection. When selecting conduits for use in corrosive environments, it is important to consider the long-term cost of ownership. While stainless steel conduits may have a higher initial cost, they may also have a longer lifespan and require less maintenance than galvanized rigid metal conduits. Therefore, it is important to weigh the initial cost against the long-term benefits when making a decision. Regularly inspect the galvanized rigid metal conduits for signs of corrosion. Look for rust, pitting, or other signs of deterioration. If corrosion is detected, take steps to address the problem promptly to prevent further damage. Clean the galvanized rigid metal conduits regularly to remove dirt, dust, and other contaminants that can contribute to corrosion. Use a mild detergent and water to clean the conduits, and avoid using harsh chemicals or abrasive cleaners. Apply a corrosion-resistant coating to the galvanized rigid metal conduits to provide an additional layer of protection. There are many different types of coatings available, so choose one that is appropriate for the specific environmental conditions present. Consider using cathodic protection to protect the galvanized rigid metal conduits from corrosion. Cathodic protection involves applying a small electrical current to the conduits, which helps to prevent corrosion. Implement a regular maintenance program to ensure that the galvanized rigid metal conduits are properly protected from corrosion. This program should include regular inspections, cleaning, and coating applications. Keep detailed records of all inspections, maintenance activities, and repairs. These records can be helpful for tracking the condition of the galvanized rigid metal conduits over time and for identifying potential problems early on. Consult with a qualified electrical engineer or corrosion specialist to obtain expert advice on the selection, installation, and maintenance of conduits in corrosive environments. They can help you to choose the right materials, implement effective corrosion control measures, and ensure that your electrical system is safe and reliable. The NEC requires that all electrical equipment be installed in accordance with the manufacturer's instructions. Therefore, it is important to read and follow the manufacturer's instructions for the galvanized rigid metal conduits that you are using. The NEC also requires that all electrical equipment be approved for the intended use. This means that the galvanized rigid metal conduits must be listed by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. Ensure that the galvanized rigid metal conduits are properly supported to prevent them from sagging or bending. Use appropriate hangers, clamps, or other support devices. Protect the galvanized rigid metal conduits from physical damage. Avoid running the conduits in areas where they are likely to be struck by vehicles or other objects. Do not overload the galvanized rigid metal conduits with too many wires. Follow the NEC guidelines for conduit fill. Avoid mixing different types of metals in the same raceway system. This can lead to galvanic corrosion. Use compatible fittings and connectors with the galvanized rigid metal conduits. Ensure that the fittings and connectors are also galvanized to provide corrosion protection. Make sure that all connections are tight and secure. Loose connections can create a fire hazard. Ground the galvanized rigid metal conduits properly. Follow the NEC guidelines for grounding. Inspect the galvanized rigid metal conduits regularly for signs of damage or corrosion. Repair or replace any damaged or corroded conduits immediately. Keep the galvanized rigid metal conduits clean and free from debris. Avoid using harsh chemicals or abrasive cleaners on the conduits. Follow all applicable safety precautions when working with electrical equipment. Wear appropriate personal protective equipment, such as gloves and eye protection, to energize the circuit before working on any electrical equipment. If you are not qualified to work on electrical equipment, hire a qualified electrician. Always consult with a qualified electrical engineer or corrosion specialist if you have any questions or concerns about the selection, installation, or maintenance of conduits in corrosive environments. Consider specifying a higher grade of galvanized coating for increased corrosion resistance. Explore the use of supplementary corrosion inhibitors or coatings applied to the installed conduit. Conduct periodic potential measurements to assess the effectiveness of cathodic protection systems. Investigate the use of alternative grounding methods that minimize corrosion risks in harsh environments. Implement moisture control measures within the seal structure to reduce humidity levels. Analyze the chemical composition of any fluids or gases present in the environment to identify potential corrosive agents. Employ corrosion-resistant hardware and fasteners for all conduit supports and accessories. Ensure proper ventilation within the seal structure to prevent the buildup of corrosive fumes. Document and track all maintenance and repair activities related to the conduit system. Provide training to personnel on proper handling, installation, and maintenance practices for conduits in corrosive environments. Conduct regular audits of the conduit system to identify and address potential corrosion risks. Establish a proactive corrosion management plan that outlines procedures for inspection, monitoring, and mitigation. Regularly review and update the corrosion management plan to reflect changes in environmental conditions or operational practices. Implement a system for tracking and analyzing corrosion-related failures to identify root causes and prevent recurrence. Foster a culture of corrosion awareness among all personnel involved in the design, installation, and maintenance of the conduit system.